Welcome to my channel, dear student. And today this is a video mainly is about how to expand a function of a certain condition. In this video, I will mainly benefit those of students who will sit for the class 10+2 competitive exam, and those who will study after the higher. Okay. In this video, I will explain mainly how to expand of a function. So let's start. Let a polynomial, polynomial like y is equal to f of x, that is equal to a naught, a1x, a2x square, a3x cube, a4x to the power 4, an x to the power n dot to infinity. Okay, dot to infinity for that. Okay, now if we differentiate, now first put here 0, then every value of this term is 0 except a naught, so we got here a naught. Now differentiate this function f dash, that is x, and this is b0, so we got here a1, so this is here twice x a2, this is here thrice x square a3, okay, 4 x to the power q a suffix 4 dot 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 dot, and this is n into x to the power n minus 1 a suffix n dot dot to infinity actually. Okay, and now again put here 0, so we got here a1. Okay, got here a1. Again differentiate this with respect to x, and this is 0, we got here 2 into a2 and 6 into x a3 and 12 into x square a4, so n into n minus 1 x to the power n minus 2 an. Okay, so again if we put 0, add 0, so we got here a2. Again differentiate with respect to x, this is the third order differentiation, we got 6 into a3, and this is here 24 into x a suffix 4 dot dot to infinity. Then if we find at 0, so what will be the value of that? That is here 6 times of a3. Same as for the fourth order differentiation, we got here 24 a4 plus dot dot dot. So see, this is here constant and remaining all are the variable with related with x. So you can clearly find the value, the fourth order derivative at 0 is equal to 24 a4. Okay, so now again rewrite the formation a naught, f of 0 is equal to a naught. Now a1, this is equal to f dash a naught. Now a2, that is equal to 1 by 2, and this is f double dash 0, and mainly I want to write here, this is 1 by factorial to f dash 0 here, and same as this is by factorial 1, and after that a3, and this is can be also expressed as 1 by 6, so 1 by 6 can be expressed as factorial 3, and this is okay, and the a4, and this also I have see 1 by 24, and 1 by 24 means this is the factorial 4 actually. Okay, factorial 4, and this is the fourth order at 0. Similarly, a suffix n, it can be expressed also like factorial n and the nth order derivative. Okay, this is an nth order derivative. So put this formation like a0, a1, a2, a3, a4 and nth order a suffix n to the polynomial of that. So this is 1. Okay, now from 1, okay, this is y is equal to f of x and that is equal to a0, means this is here f0. Okay, a1, this is here x into f dash 0 by factorial 1. This is here x square a2 actually a2, this is 1 by f double dash 0 and by factorial 2, and this is x cube f triple dash 0 by factorial 3. Okay, same as x to the power 4 at 0, this is by factorial 4, and this is x to the power n, this is the nth order derivative, this is factorial n, and this is dot dot to infinity. So this is the, again rewrite here, this is f of x and this is f naught 0, f naught, and x by factorial 1 f dash 0, x square by factorial 2 f double dash 0, x cube by factorial 3 f triple dash 0, x square 4 by factorial 4 fourth order 0. After the nth order derivative, we got here x to the power n by factorial n and nth order at 0. Okay, so this is the formulation of a function. If we can easily use this formula, expand a function. For example, I want to give a example, that is here f of x e to the power x. Now expand this as the ascending power of x. Expand this ascending powers of x. Okay, so see, first if we differentiate, we got here e to the power x, again second order we got here e to the power x, again third order we got here again e to the power x. Similarly at 0 we got here 1, first order at 0 again 1, second order at 0 again 1, and third order at 0 again 1. So f of nth order 0 again 1. So therefore this is the formula, f of x is equal to expansion of e to the power x. So we can write e to the power x here. So add f0, we got here 1. Now x by factorial 1, f dash 0, we got here 1. Then x square by factorial 2. Then f dash 0, f double dash 0 at 1 is this. Okay, so cube by factorial 3 and dot dot, same as x to the power n by factorial n and dot dot to infinity. Okay, so this is the expansion of e to the power x. Okay, see carefully, and now I also expand the other function c. Okay. This very important question, students, carefully, very interesting. It is more helpful to all of you. Okay. Now expand sin x. Sin x, cos x, logarithm of 1 plus x to the base e. Okay. See, for sin x, expansion of sin x in ascending power of x. These all are ascending power x. Okay, expand this ascending power of x. So this is the function sin x. If we differentiate, so this is a f dash x. We got here cos x, and cos x can be expressed as like, see here, pi by 2 plus x. Okay, and now see f double dash x, the derivative of sin x. It is also cos of pi by 2 plus x. Again, pi by 2 plus x can be expressed as like 2 times of pi by 2 plus x. Again, differentiate third order derivative. Actually, this is cos of 2 times of pi by 2 plus x, and it can be expressed as 3 into pi by 2 plus x. Okay, from that, after the nth order derivative, successive derivative, see third order, then we got here 3 here. Okay, after the nth order, and this is the n multiple of pi by 2 plus x. So similarly, we can find at 0. So this is here 0, and f dash 0, we put here 0, then we got here 1. Again, f double dash 0, at this we got here 0, then cos 90 is 0 also. Okay, and the third order, see third order, see here third order, if we put here pi, then we got here minus 1. See, this is here 0, so this is here pi, cos pi is equal to minus 1. So see, so after the nth order derivative, this is here the n multiple number of pi by 2. Okay, so use the formula. This is y is equal to f of x, and this is equal to sin x, and that is the formula. Again, write f0 x by factorial into f dash 0, x square by factorial into x, this is f double dash 0, x cube into factorial 3 into f triple dash 0, dot dot x to the n by factorial into nth order derivative at 0, so dot dot to infinity. So therefore the sin x, f0, at f0 we got here 0, okay, and x by factorial 1, f dash 0, so f dash 0 here is 1. Okay, now x square by factorial 2, f double dash 0 is 0 here, and the x cube by factorial 3, and factorial 3, this is here minus 1. Similarly, this is x to the power n y factorial n, and this is sine of n into multiple number of pi by 2. Okay, so again write x, and this is x cube by factorial 3. Okay, and this is the general term, n into pi by 2. Okay, this is the expansion of a sine series. Okay, now expand the cos series. Expand the cos series. Actually, this expansion only expand to the infinite series, not a finite. So f of x, this is here cos x, differentiate, we get here sin x minus, then find 0, and this is 0, and differentiation. And now if we it can be expressed as a general formation, this is cos of pi by 2 plus x actually, then you got here minus sin x. And now if we differentiation x and the derivative of cos x and derivative of sin x, okay, and it can be expressed as a cos x, so minus no needed to find it. Okay, minus this is cos x. Okay, therefore f dash 0 is equal to minus 1, same as triple dash, third order derivative. This is cos, differentiation of cos is here sine, so at 0 we got here 0. And the fourth order, this is here cos x. Okay, this is here 1. Again fifth order, this is as minus sin x, again 0. And the sixth order, derivative of sin x is cos x, so this is minus cos x. Therefore, at 0 we got here minus 1. Now, the general formation of that, if f of x is equal to cos x, so the f dash x is equal to cos of pi by 2 plus x, same as after the nth order derivative, we got here the cos of n times pi by 2 plus x actually. Therefore, the nth order derivative of 0, and this is the cos of n multiple of pi by 2 here. Therefore, you can use the formula of expansion, that is the formula is this. Therefore, y is equal to f of x is equal to actually cos x, and this is here f0 x by factorial 1 f dash 0 x square by factorial 2 f double dash 0, and like that see x square n by factorial n, nth order derivative 0 and order to infinity. So f0, so f0 means here okay, f0 means cos 0, so this is 1, so this is 1. Okay, x by factorial 1 f dash 0 is 0 here, so x square by factorial 2 f dash 0, f double dash 0 is minus 1 here. Again x cube by factorial 3, this is f triple dash 0 is 0 here. Same as x to the power 4 by factorial 4. Okay. This is here 1. X to the power 5 by factorial 5. 5 is 0 here. Okay. And for the sixth order derivative is here minus. So x to the power 6 by factorial 6, this is minus 1. After the nth order derivative, we got here x to the power n by factorial n and cos of n number multiple by pi by 2 and dot to infinity. So this is here 1 minus x square by 2 factorial 2, and this is 0, and this is here x to the power 4 by factorial 4, and this is 0, and this is x to the power 6 by factorial 6, like that. And general formation here is x to the power n by factorial n and cos of n pi by 2 plus dot to infinity. Okay, this is the expansion of cos series. Okay, this is the expansion of cos series, and this is the expansion of sine series. X minus x cube by 3, 1 minus x square by factorial 2. Okay. Okay. Now for the expansion of logarithm function. Okay, log of 1 plus x. See. And these type of expansion in ascending power of x. Okay, after the expansion of logarithm, how to expand in ascending power of x minus 1, x minus 2. So here we use here the Taylor series as a form of Maclaurin series. Okay, so first expand the logarithm series. For that, f of x is equal to log general logarithm to the base of a is this. Okay. So here, if we differentiate, then we got here 1 plus x1 by 1 plus x to the power minus 1. So therefore, at 0, we got here 1. If we differentiation of f dash double dash x, so we got here minus 1 and 1 plus x whole to the power minus 2. Therefore, f double dash 0, and it will be minus 1. Okay, and after the first order, we get a second order, and we get a third order, and this is minus 1 minus 2. So I want to write like that pattern. Why we write here like that? See, actually this is the formation of minus 1 whole square, and this is factorial 2. After the nth order derivative, what happened in the formation, general formation, I want to write like that. Okay, 1 plus x will be minus 3. So this is here. Okay, minus 3. So therefore the general formation is that. Therefore after the nth derivative, this is n times of derivative is not 0. Okay, so nth order derivative, and this will be, see here, third order, we get here minus 1 whole to the square. So the degree here is a 1 less, so minus 1 whole to the power n minus 1. So this is here n minus 1. This is here 1 plus x whole to the power third order. The power here is 3. Okay, like that. This is n. See. Okay. So actually third order, in that case third order differentiation value is actually 2. Okay, and now for the fourth order, see, minus 1 whole cube factorial 3 and 1 plus x whole to the power minus 4. Therefore at 0 here is minus 6. Okay. So therefore the y is equal to logarithm x. Okay, so to the base e here, and that is equal to f0 x by factorial 1 f dash 0 x square by factorial 2 f double dash 0 x to the power cube by factorial 3 f triple dash 0. Okay, dot dot x to the power n by factorial n any order derivative 0 dot dot to infinity. And for that f0 for that f0, or if we find f0, then we got here only 0. So log of 1 is 0 actually, so this is 0. For x by factorial 1 f dash 0, f dash 0 means here 1. Okay, so x square by factorial 2 f double dash 0, f double dash at 0 is minus 1. Okay, x cube by factorial 3 f triple dash 0, triple dash 0 here is 2 x to the power 4 by factorial 4. Okay, this is here third order, and fourth here is minus 6, and dot dot x to the power n by factorial n. After the nth order derivative, this is, we got here, this is minus 1 whole to the power n minus 1 and into factorial n plus so factorial n minus 1. Okay, see, okay, now rewrite here x minus, this is here x square by 2 plus 2 are cancelled, so x cube by 3 here minus, actually this is here 6 factorial 6 also. Okay, and 4 into factorial 3, and this is cancelled, so this is x to the 4 by 4, and now x to the 5 by 5, like that. Okay, and dot dot. Okay, and if we simplify this, we got here minus 1 whole to the power n minus 1. This is a general formation, general term, and this is here n plus dot dot to infinity. So this is the logarithm series. Okay. Okay, now, and these all are the, see, this is the power of ascending powers of x. So in your some question would be arise here, like expand this as this ascending power of x minus 1. So then what can I do? So in that case we use the formula of Taylor series. Okay, so see, what is the Taylor series? A Taylor expansion. So Taylor theorem with Cauchy's form of remainder. That is actually f of a plus h, and that is equal to f of a plus h into, this is here f dash a, and h square by factorial 2, h square by factorial 2 into f dash double dash a, and this is our h cube by factorial 3 into triple dash a. Okay, and the general form is, you know, this is h to the power n minus 1 factorial n minus 1 and the nth order derivative of a, and the remainder part here is h to the power n 1 minus theta to the power n minus 1 over factorial n minus 1, and this is the nth order derivative a plus theta h, where theta lies between 0 to 1. Okay, so see, in that case, this is the Taylor theorem. Use this form. We from another form, let a plus h is equal to x. So therefore f of x here, and that is here f of a plus x minus 1, this is here by factorial 1, and f dash a. Okay, see x minus a, h x minus a actually. Okay, now for h x minus a whole square by factorial 2 and f double dash a. Okay, x minus a whole cube by factorial 3 f triple dash a, and like that. Okay, so only the needed to here expansion, so I'm not writing the remainder pattern. So only the 3/4 term of this series for expansion. So now expand e to the power x ascending powers of x minus 1. Now e to the power x ascending power of x minus 1. There is a clear view. See, now we want to get here as a, this is the ascending power of x minus a whole square. So now I want to get a power like x minus 1 in ascending power of x minus 1. So we want to get here x minus 1, this is our x minus 1, this is our x minus 1. So in place of a, I will put the value in place of a, that is 1. Okay, so see, first we differentiate the function like here f of x. So this is here e to the power x. Now differentiate what we get here e to the power x. So f dash double dash x, so we get here e to the power x, again f triple dash x, then we get here e to the power x. Okay, after the nth derivative, so this is the nth derivative, we got here e to the power x. So now find here f of a, actually f of a. Now we want to get here f of 1. See, in place of a we want to get here 1. So that's why this is 1. So e to the power, now first I put here a, after the ending we can put here 1. So e to the power a actually, and then f dash a, we got here e to the power a, f double dash a, e to the power a, and c nth order derivative of a, we get here e to the power a. So f of x, this is here the expansion of in powers of x minus a actually. Okay, so we put here f of a, so e to the power a, and this is here x minus a by factorial 1 into the e to the power a, x minus a whole square by factorial 2 into e to the power a, x minus a whole cube by factorial 3 into e to the power a. So like that, same as x minus a whole to the power n by factorial n, this is e to the power a, this is the general formation to infinity series. So okay, now I want to get here ascending powers of x minus 1 as the power is x minus ascending power powers are powers of x minus 1. So putting a equal to 1, then so f of x is equal to, this is e to the power x, so put here 1, so e to the power 1 x minus 1 by factorial 1 e to the power 1 x minus 1 whole square by factorial 2 into e to the power 1 x minus 1 whole cube by factorial 3 into e to the power 1. So this is here x minus 1 whole to the power n by factorial n, and this is e to the power 1 dot dot to infinity. We take common here e, so we got here 1 plus x minus 1 by factorial 1 x minus 1 whole square by factorial 2 x minus 1 whole cube by factorial 3, okay, x minus 1 whole to the power n by factorial n, so dot dot to infinity. Okay, so this is the ending part to this video. I think all of you have better understood, and if you enjoy the video, then share this video to all your friends, and don't forget to subscribe my channel. Thank you.